Hi all, Mads Barnkop from Kaizer Power Electronics here. Today we're taking a look at this APC Smart-UPS 1500. Let's do a complete teardown and find out what's inside. At the front of this 1500 watt UPS we have a indicator for load, we have a indicator for battery, a unbalanced LED, we have a sine wave and battery dead status. Then we have overshoot, sine wave and downgoing load. Not too sure about the upgoing and downgoing, maybe that is charging symbols. We have a test button and a power button. Behind this lid we also have the battery holder and battery replacement plate. Sits with two screws. Says here 24 volt 10 amp hours batteries. So let's see how many of those are in there. At the back we have a serial port for configuration. We also have a USB port. And here we can see we're actually missing the classic telephone line protection board. What a shame if that's even used anymore. It says here it weighs over 18 kilograms. We have a external battery connector, which seems to be a bit proprietary. Install prior to operation, remove prior to transport. Okay, so maybe this is actually just short-circuiting the battery and connecting it to the power circuit. We have a single input, we have a overload protector, resettable fuse, and we have 8 outputs. The 24 volt battery pack consists of two 12 volt cells put in series. The bridge here at the input is missing, and at the connector we also have a fuse, which is kind of weird, sitting between plus and minus. Probably not a fuse, maybe a over voltage protection. And there is really no marks on this battery pack, except it is a genuine APC battery cartridge. And as of that, has no real ratings on it. So it is actually a 100 amp fuse. And the placement makes absolutely no sense. So I guess those who took this apart have just turned the battery pack around, because it would make sense to put a 100 amp fuse at this point in a series connection, so you break the series connection between the battery packs at a high fault current, but certainly not have it sitting over here and a missing bridge here. So that explains the weird configuration. As with many of these smaller compact units, it's like it's going completely apart in one piece. And this is no exception. It seems to be held together by wires on the inside while everything is loose, but at least we can say that this had forced air cooling into a pretty rudimentary homemade heatsink there. But let's try to get this taken apart. The output choke here, we can see that it's actually connected to the heatsink of the full bridge. So that is the two legs that needs a choke across them. So we'll get that dismounted before going on. We have the 230 volt AC input on the black and white wire over here. Goes up around some relays to switch between the main supply or UPS supply. We also have some line filtering sitting here, so we have mains voltage going in through the line filters over to the first relays sitting over here. The outputs connect over here. What we see is some filtering. We have the, before I said that we had the large choke, but that is of course the output transformer. We have two small chokes sitting right here with some capacitance for the output filtering. Down here we have the serial interface. The plastic cover over the heatsinks here is a pretty dead giveaway that these heatsinks are actually live. So these are energized with the plus and minus of the bridge. And judging on the capacitor here, which is a 2700 microfarad at 40 volt, That is a low voltage from the 24 volt DC battery pack. The first breakout board we have here is the USB connection, which actually has its own controller running at 24 megahertz. That is most likely faster than the main controller sitting down here. The crystal sitting next to the main controller is 16 megahertz, and the sticker on here says Smart-UPS 4G. So that's most likely the 4th generation, revision 12, and Mark 2003. So that is over 20 years old, this unit. Front panel, status and input board. Not much to say about that. Perhaps not visible on video, but this is perhaps a Atmel M87C51 microcontroller. The full bridge inverter uses HRF 3205 MOSFETs, which are rated for 55 volt DC at 100 amps and a very low on resistance at 0.008 ohm. So that is a pretty nice MOSFET. Still a TO220 package, and as we can see we have 2 sitting and we have 4 heat sinks. So we are actually running 2 in parallel, and if we check out the board down here, we can actually see it has markings for an additional 2 MOSFETs. And also a diode sitting out here. So this design is perhaps modular and can be used in many of their different UPS specifications and sizes. Thank you for watching the teardown of this 1500 watt UPS. I hope you learned something about the power electronics and what goes on inside a uninterruptible power supply. So until next time, see ya.